So now we're going to have a look at a set of hypothesis tests which are described as distribution-free hypothesis tests. Now there's three types of these. We're going to start off by looking at the sign test. However, for all distribution-free tests, they are non-parametric and distribution-free. And what both these words mean is that non-parametric means that the data is not required to fit the normal distribution, usually uses ordinal data, meaning that it does not necessarily use numbers, but is dependent instead on rank. Also, distribution free means that we do not rely on assumptions about the data, that the data was drawn, from a given population distribution. Okay, so we're saying that it's not necessarily drawn from a normal distribution or a rectangular distribution. It can be drawn from any distribution. Now, specifically for the sign test, we're looking at doing this with single and paired data. We're only going to look at single sample data in this video. As part of the test, we perform a binomial calculation, and therefore we end up having to look at the significance level if it's one-tailed and half the significance level if it's two-tailed. And the sign test, we're comparing the population median, which is using this eta symbol here. Any value which is the same as the median, we're going to ignore in the number of trials, and you'll see what I'm talking about in a little while. And because we're comparing things with the median, our probability when we change it to a binomial is going to be 0.5 because the median is halfway through the data. So for one tail with a single sample of data, here we have a psychologist carried out an experiment to find how many 6-letter words 24 randomly selected students can recall from a list of 20 such words. The results are here. From the previous experiment, it is known that the median number remembered for the population as a whole is 15. Test at 1% significance level the hypothesis that students have a lower median recall value than the population as a whole. So our H0 is going to be that the median is still 15, and our H1 we're seeing if they've got a lower median, so that means that the median is going to be less than 15. Now we need to go through these, and what we're going to do is we're going to compare each number to the value of 15. When it's more than 15, we're going to give it a plus sign. When it's less than 15, we're going to give it a minus sign. And if it's the same as 15, then we're going to put a dot, and we're not going to count that anymore, as I explained in the introduction part. So because 12 is less than 15, that gives us a minus. 14 is less than 15, so that gets a minus. 15 is the same as 15, so that gets a dot. 8 is smaller than 15, so that gets a minus. 7 is smaller than 15, so that gets a minus. 10 is smaller than 15, so that gets a minus. So you can see how I've compared each of the values on the top row there with the value of 15. Now I'm going to do the same with the second row. So 11 is smaller than 15, so that gets a minus. 15 is the same as 15, so that gets a dot. 17 is bigger than 15, so that gets a plus. 18 is bigger than 15, so that gets a plus. 14 is smaller than 15, so that gets a minus. And 15 is again the same as 15, so that gets a dot. Then on to the next one. 7 is smaller than 15, so that gets a minus. 9 is smaller, so that gets a minus. 10 is smaller, 11 is smaller, 13 is smaller, and 13 is smaller. Then on the last row, 15 is the same, 16 is more, 12 is less, 14 is less, 8 is less, 12 is less. So now we need to add up how many pluses and how many minuses we have here. So the total number of minuses that we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The total for the pluses is 1, 2, 3. And altogether there we have 20. Well, we started off with 24 people and we have 4 dots that we're no longer counting. So yes, that looks about right. So now, as I explained before, we're going to change this into a binomial. The binomial becomes x follows a binomial distribution, and the n comes from adding the total of minuses and the total pluses together. So that gives us 20. And as I explained before, the probability is 0.5. Now, because I want to make this as simple as possible, we're always going to choose the smaller of these two to be the one that we're looking at the probability from. So in this case, it's going to be the t plus, the 3 there. T plus is 3. And that means that we're looking at the probability that x is less than or equal to 3. Now, the nice thing about always choosing the smallest of your two totals is that it will always be less than or equal to. So you don't need to worry about, is it less than or equal to, or is it greater than or equal to? It's always just going to be less than or equal to. And that makes it simple as well if you've got one of the older styles of calculator. So then we go into stat, dist, binomial, BCD. Our lower is going to be 0. Our upper is going to be 3. If you've got the older style of calculator, remember that means that your x is just going to be 3. The number of trials, as I've wrote here, is 20. And the probability is 0.5, and it's always 0.5 for the sign test. So that gives us 0.00129. That is our test statistic. The critical value is going to be the same as the significance level because it's one-tailed, which is 0.01. And we draw our conclusion in the same way. The chance of this happening is more rare than what we were looking at. So as the test statistic is smaller than the critical value, we reject H0 at a 1% significance level. There is sufficient evidence to suggest and because we're talking about the median, so the median recall of and I believe it was 6-letter words. Yes, 6-letter words. Is lower than 15. So now we're going to have a look at another example. So this time, as you can see, we don't have numbers. We have a random sample of 20 children are asked whether they like Frosted Flakes, breakfast cereal. The children reply yes or no, and their results are summarised below. Use the sign test at 1% significance level to test if children like Frosty's breakfast cereal. So, because we're going to determine like as being more than half, so H0 is going to be that the median is half. There's 20 people, so we're looking at 10. And our H1 is going to be that the median is more than a half, so more than 10 people like it. So that means I'm going to put my yeses as pluses and my nos as minuses, like this. As we did before, we're going to add them up. So T plus is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 said yes. 3 said no. So again, we've got x squiggle b, 20, because that's 17 add 3 put together, 0.5. And we're looking at the probability that x is less than or equal to 3. Well, this is actually the same probability as what we found in the first example, which gives us 0.00129 to 3 significant figures. That is our test statistic. Again, it's a one-tailed test, so our critical value is just 0.01. So then, as statistic is less than our critical value, we're going to reject H0 at a 1% significance level. There is sufficient evidence to suggest the median number of people who like Frosties is more than half. And you could add a statement there saying that children like Frosties breakfast cereal. So I'd now like you to pause the video and give the two now you try questions a go, remembering to be careful when you're doing your pluses and minuses, and that if any value is the same, that we put a dot for that and we don't count it anymore. So hopefully you paused the video and gave the now you try a go. For the first one, we have a factory produces lengths of ropes for use in boat yards. The breaking strength in kilograms for a random sample of 14 lengths of rope are as follows. Gemma believes that the median breaking strength is greater than 135 kilograms. Test Gemma's hypothesis tested at a 5% significance level. So here our H0 is that the median is 135, our H1 is that the median is more than 135. You can see there that we've done our pluses and minuses referring back to the value of 135, so 134 is smaller than 135, 136 is bigger than 135, and so on, which gives us 10 pluses and 4 minuses. When we add those two values together, we get 14. 10 add 4 is 14. And when we're choosing which one to find the probability that it's less than or equal to, remember that we use the smaller one. So less than or equal to 4, which gives us 0.0898. That's our test statistic. Our critical value is 0.05 because it's one tail. So as our test statistic is bigger than the critical value, we accept H0 at 5% significance level. There is insufficient evidence to suggest that the median breaking strength is more than 135 kilograms. So then for the second now you try question, we've got the lifetime in hours of a randomly sample of 10 extra long light bulbs taken from a large batch produced in a factory after an expensive machine overhaul were here. And before the overhaul, the median lifetime was 500 hours. Use a sign test at 5% significance level to test the hypothesis that the median lifetime has increased after the overhaul. So our H0 is that the median is 500. Our H1 is that the median is more than 500. And again, you can see that we've done our comparisons there, which gave us 7 pluses and 3 minuses. Again, 7 add 3 gives us 10. And choosing the smallest one, which would be the 3 this time, and then looking at the probability that x is less than or equal to 3 gives us 0.172. That's our test statistic. The critical value again is 0.05 because that was our significance level. And then as the test statistic is bigger than the critical value, we accept H0 at 5% significance level. There is insufficient evidence to suggest that the median lifetime is more than 500 hours. And you can add another bit there after the overhaul so that they know which bit we're talking about. So we're going to have a quick look at two-tail hypothesis testing. So remember that this time when we're deciding on our critical value, it's going to be half the significance level. So here we've got 21 students at a large college undergo a standard test to measure their reaction time to a particular stimulus. The median reaction time for the population in general is believed to be 7.8 seconds. The reaction time for the sample R, and we've got our results there. Use a sign test to test at a 5% significance level the hypothesis test that the median reaction time is 7.8 seconds. So remember, whenever we're trying to prove that something, well, not prove, but perform a hypothesis test to see if something is still the same, that is still a two-tail hypothesis test. So our H0 is going to be that the median is 7.8. Our H1 is going to be that the median is not 7.8. We still do our pluses and minuses in the same way though. I'm going to do it next to the numbers up here just so it's a bit easier for me to see them. So we've got 6.6 is less, 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 more, less, more, less, less, same. So that gets a dot, remember. Less, less, more, less, more, less, 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 more, less, less. So it's a bit hard to do with the decimals, but I think I've managed to get them all right. So the total number of minuses we've got is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the total of pluses that we have is 1, 2, 3, 4, 5. We've got one dot and it said that there were 21 to begin with, so I have counted them all. So now we'll have x follows the binomial distribution. 15 add 5 gives us 20. Remember that we're adding these together, not counting how many pieces of data we had all together at the beginning. Because we're testing the median, the probability is 0.5. We still choose the smallest one, which is 5 in this case. And as I said, because we're choosing the smallest one, we're looking still at the probability of x being less than or equal to 5. And it's always less than or equal to as long as you choose the smallest one. So then in our calculator, lower is 0, upper is 5. Remember, if you've got an old style of calculator, that'll mean just x is 5. The number of trials is 20. The probability is still 0.5. And that gives us 0.0207. That's our test statistic. And as I said, because this time this is a two-tail test, that means my critical value is going to be 0.025, as it's half of our 5% significance level. So then as the test statistic is smaller than the critical value, we're going to reject H0 at a 5% significance level. There is sufficient evidence to suggest the median reaction time is not 7.8 seconds. Oops. And in the same way as we had with binomial, every time we have a two-tail hypothesis test, it's always going to have not in the conclusion. So now I'd like you to pause the video and give the Now You Try a go. Okay, so hopefully you paused the video and you gave the Now You Try question a try. As you can see here, I've done my pluses and minuses in different colours this time just so it was easier to see, as I've done it next to the data and it was quite close together. So this time we had 25 subjects undergo a test in a controlled laboratory experiment where recorded as having the following reaction time to a particular stimulus. Very similar situation as what we had last time. Carry out a sign test at 5% significance level to test the hypothesis that the median reaction time the population of subjects were drawn is 7.5 seconds. So our H0 is that the median is 7.5, our H1 is that the median is not equal to 7.5. The total number of minuses that we have is 18 and the total number of pluses we have is 7. 18 plus 7 gives us 25 and there was 25 to begin with, so that's good, and we've got no dots. So we've got x will be 25, 0.5. The smallest out of 18 and 7 is 7. So we're looking at the probability of x being less than or equal to 7, which gives us 0.0216. That's our test statistic. Our critical value is half our significance level, which is 0.025. So as the test statistic is smaller than the critical value, we reject H0. At 5% significance level, there is sufficient evidence to suggest that the median reaction time is not 7.5 seconds. So next time we're going to have a look at how we perform the sign test when we are given more than one set of data. Thank you very much for listening.